Welcome to the Tao Salon in Statistics. Today, we're pulling back the curtain on the secret sauce of modern statistics. We're talking about the hidden engine that powers almost all the models you see every day, from business forecasts to major scientific breakthroughs.
You see this little expression right here? It might not look like much, but it is the absolute backbone of modern statistics. And here's the wild part. A ton of people who use models built on this principle every single day have no idea it's even there.
So what is this powerful theory, really? And why is it so incredibly crucial for anyone who works with data? Well, let's dive in and break it all down.
To really get this, we have to start with one of the most fundamental problems in all of statistics, the problem of estimation, or as I like to call it, the art of the educated guess.
Think of it this way. We build models to be like simplified maps of the real world, which is, incredibly complex. These maps have key features, we call them parameters, that we really want to understand. The only catch? We can't see them directly. They're hidden, and we need a smart way to figure out what they are.
We have to infer their values, or estimate them, using the data we actually have. And that is exactly where maximum likelihood estimation steps onto the stage and becomes the star of the show.
Okay, enough with the theory. Let's make this super concrete with a simple, hands-on example. It's really the best way to get a feel for this idea of likelihood.
So imagine my cousin hands me a loaded die. All I know is that it likes to land on 6. My mission then is to figure out the exact probability of rolling a 6, we'll call that probability pi, just by rolling the dice and seeing what happens. So I roll it one time, and boom, it's a 6. Now, based only on this one piece of data, what's my best guess for the probability? Well, 100% probability is the only value that would have guaranteed that outcome. So for now, our likelihood function peaks right at 100%. It's the most plausible answer so far.
But watch what happens when we collect more data. I roll it 4 more times. This time, I get 2 more 6s, but also 2 rolls that weren't 6s. The likelihood plot completely changes. Now that we've seen both outcomes, the probability can't possibly be 100%. The new peak, the value for our probability that is most likely to have given us this exact set of results, is now sitting at 60%.
And that, right there, is the beautifully simple idea at the core of maximum likelihood estimation. We choose the parameter value that makes the data we actually observed the most probable. We just find the peak of that likelihood curve.
Now, this simple idea is ridiculously powerful. And that's because of the amazing qualities, or let's call them superpowers, that it gives our estimates. These were championed by the legendary statistician R.A. Fisher, and they're what make MLE so special.
First up, superpower number 1, consistency. This one is super intuitive, it just makes sense. It means that as you collect more and more data, your estimate gets closer and closer to the true value you're looking for. More data, better guess. MLE guarantees it.
Have you ever been staring at a regression output, looking at those z-scores or t-scores, and just wondered, where do those numbers actually come from? How can we be so confident in them?
Well, the answer lies in the second superpower, asymptotic normality. It sounds a little complex, but all it really means is that for large samples, the distribution of our estimates starts to look like a predictable bell curve. And that is the magic key that unlocks our ability to reliably calculate all those p-values and confidence intervals.
Now, when we're talking about confidence intervals, we want them to be as tight and precise as we can get, right? That means our estimate needs to have the smallest possible variance. So how do we get that?
That brings us right to our final superpower, asymptotic efficiency. This one's a big deal. It means that, under the right conditions, the maximum likelihood estimate has the smallest possible variance you can get. It's the most precise guess you can make, hitting a kind of fundamental statistical speed limit for how good an estimate can be.
Okay, so we've seen its power. Now, before we wrap this up, it's really important to talk about the fine print and then the big takeaway for anyone using this stuff out in the wild.
So, MLE isn't a magic wand. These amazing properties are asymptotic, which is just a fancy way of saying they really kick in with large samples. You also have to make sure your model and data meet certain assumptions. So look, it's not a silver bullet for every single problem, but it is the solid bedrock for the vast majority of them.
So why does this all matter to you? Whether you're in business, marketing, or doing consumer research, let's just boil it down. Consistency means your findings actually get more reliable the more data you have. Normality means you can genuinely trust the p-values and the confidence intervals in your reports. And efficiency means you're getting the absolute sharpest, most precise insights possible from your data. Simply put, your models are built on a foundation that's reliable, testable, and incredibly powerful.
Maximum likelihood estimation is that engine humming away under the hood of so much of the analysis we all rely on. Understanding it means you're not just running the numbers, you're understanding the logic and the story they're telling. So the next time you see a statistical report, you'll be able to look at it with a whole new level of insight and confidence.